Hello everyone, I hope you all are fine. I am Niranjan, lecturer at SLGTI, your engineering material lecturer. This is our second video. Previous video I explained our main topic thermal equilibrium diagram. Under that we are going to study heating curve. Before moving today's lesson, we are going to make a summary of previous video. So previous video I stopped in this slide. Here this is my heating curve. The y-axis represent of temperature and x-axis represent of amount of heat added. So I started here. When we are heating up solid material, the temperature will increases up to melting temperature. So here melting will start. We can find 100% solid. When we heat further for the solid material, the temperature will never change. It means constant up to solid material change their phase. Here we can find 100% liquid, means in this point melting will end. So here I gave the reason also. This is my solid material and also this is my liquid material. This is physical state. If we go to further in the intermolecular level, you can see the bond length difference between solid and liquid. Means the liquid bond length is very high when compared to the solid. Therefore, the segment BC, the energy is going to and increasing the distance between neighboring molecules and overcoming intermolecular force. This energy used for the increasing the bond length. Okay students, let's move today lesson. So today I going to heat up our liquid material. Here I give some thermometer also. You can easily understand how the graph will change. So this is my liquid material. Here I am going to heat up my liquid material. I started in a C point, in a certain point. So if I heat up my liquid material, the temperature gradually increases. You can see my thermometer also gradually increases in a certain point. Here I mark that point is D point. It means in D point the liquid going to change their state. So here when heating up a liquid material, the temperature will increases. Means if I heat up my liquid material, temperature will increases. Here blank. If it is blank means this is your activity. My dear students, this is your third activity. Previous video also we did 2 activities. I think this is simple for you. I'll give time to do this around 15 seconds. You can fill this blank. Okay students, now your time will start. You have 10 seconds remaining. You have 5 seconds remaining. You can do. Okay students, I think you all did. And your answer sent through my WhatsApp. So let's move the answer. When heating up a liquid material, the temperature will increase until vaporization start. It means in this point the vaporization will start. Then here we can find 100%. In this point we can find 100% liquid. So in this temperature, here in D point the temperature is called boiling temperature. It means the liquid materials going to change their state. So here it will start to change their phase. In between C to D, we will find the liquid materials. So students, I'll give another activity also. It means when I heat my liquid further, what happened to my graph? There are 4 answers. You can find the correct answer. So here also I will give the time around 30 seconds. So you can do in a simple way. Your time is starts now. 20 seconds remaining. You can do in simple way. 5 seconds remaining. Okay students, I think you did in a correct, because previous video also you did in a correct manner. So this is simple question for you. Okay, let's move the next step. What is the answer we're going to analyze? So answer is S. It means the temperature will never change. So we can study further next slide. Okay students, here I gave the previous slide also. Now I going to heated up my liquid material further. If I heated up my liquid material further, the temperature will never change. It means the temperature is constant temperature, because in this region, here I mark D to E, in this region the liquid material completely changed their phase to gas. The second phase change is boiling. It's called boiling or vaporization. Both are same meaning. As a substance boils, the temperature stays same. It means constant temperature. In here we are going to find vaporization, and it means 100% gas. Therefore, the D to E region, the liquid material gradually change their phases to gas phase. In between D to E, we can find liquid and also gas phase. So further, we can analyze this graph. The segment DE, yeah, he mentioned, the segment D to E is boiling, because it is boiling temperature, and also in this region it is boiling. It means changing from liquid to gas phase. The temperature stays the same while the substance vaporizes. For water, this temperature is 100 degrees Celsius. This is a simple example for us, because every day we are going to use this water in day-to-day life, because the boiling point of the water is 100 degrees Celsius. In this temperature, materials to material difference. Over the course of this line segment, both liquids and gas exist various ratio. It means starting 100% liquid in a D point, it will start 100% liquid and ending 100% gas, and this is the end point here, the 100% gas phase. I think you already got my point, my dear students. So we can analyze further in this region. So let's move next slide. Here I mentioned I give liquid and gas phase. Also here I give some intermolecular picture also. This is for the liquid, this is for the gas. You can see here the intermolecular space about liquid and gas little bit different. When we compare to the liquid, gas, the intermolecular space is very high. I give some picture also. You can easily identify in here. This is solid, this is liquid, and this is gas. Here some properties to our focus interparticular space. The solid least, liquid lesser. When we gas, the more than others. The interparticle space is very high in a gas materials. And also in opposite way we can see the interparticle force of attraction very strong in solid materials, liquid material less strong, and gas materials very weak. So this is the reason the phase change need to some energy. So here the segment DE, it means this point, the energy is going to increasing distance between neighboring molecules and overcoming the intermolecular force. Therefore, the energy used internally to increase their bond length, because the bond length gas phase is very high to compare the liquid materials. Okay students, did you understand? So let's move our next topic lesson. So here I will give the little bit summary of this slide. So again I started in a solid materials. When I heated up my solid materials, the temperature will gradually increasing up to certain level. Here you can find melting temperature. Here 100% solid materials. If I heated it further, the temperature will never change. It means this is a phase change. B to C never change temperature. The C point we can identify 100% liquid. And further, I'll heated up my liquid materials. Also, that gradually increases my temperature up to boiling temperature. And we can find here vaporization start. And further, I heated up my liquid material. So the temperature will never change up to certain level. In this temperature, we going to tell boiling temperature. In E point, we can find evaporation ends. And here 100% liquid material, here 100% gas material. So let's move next. It means if I heated up gas material, what happened? It means you can tell simply the temperature will gradually increases up to certain point. So this E to F in this region we can find only gas materials. So my dear students, this is the heating curve of solid materials. I think you can get more idea about my lesson. So I stop in this video in this point. So next video we going to make a simple summary of this heating curve. So I give to you the work to make a small summary of heating curve. So we can meet next slide. Thank you very much.